Welcome back. This is the first video lesson for Unit 2. It's our second lesson, and it's all about this diagram that you see in front of you. So we have two parallel lines, and those are the black lines, and you can tell they're parallel because they have these little flags. And I can move this diagram around, and really, no matter what I do, those lines are going to stay parallel. And then this red line is called a transversal. And a transversal is just a line that intersects two different lines at two different points. So it's intersecting two lines, one at this blue point and one at this orange point. And that's what a transversal is. And it turns out that 8 angles are formed when you have a transversal that cuts through any two lines. So you can see there are 4 angles here, 1, 2, 3, 4, and 4 angles here, 1, 2, 3, 4. And we kind of zoomed in last class on this intersection or this intersection, like, right, what happens when two lines intersect. And we learned that there are congruent angles called vertical angles. So across from each other, these are going to be congruent and these are going to be congruent. And then the adjacent angles, the ones that are next to each other, are supplementary. So these add up to 180, these add up to 180, etc. So for example, right now I'm at 70-degree angles, and I can change that angle, so maybe I'll make it 100 degrees. And we still have this transversal, and these lines are still parallel. And if these are 100, then these two, I hope you realize, have to be 80, because these are a linear pair and they're supplementary. So we've got that relationship, 4 angles. And then you can see at this other intersection over here, we also have 4 angles, and it looks this way, but what we're learning about today is that these 4 angles are exactly the same as these 4 angles. We have sort of 2 intersections, and they're identical. And that only happens when our intersected lines are parallel, and in this case they are. So you can see that if we have 200-degree vertical angles here, then on the other intersection, we're going to have exactly the same. And I can change those angles, but they're always going to remain congruent to one another. Ooh, that's fun, 90 degrees. They'll always remain congruent to one another. And you can see, obviously, let me set it back to 100. If these are 100, these have to be 80, and that's why we have sort of 2 identical intersections here. And so whenever you see a diagram like this, you're always going to have 2 different angle measures. In this case, we have 100 degrees and 80 degrees. And those 2 angle measures will always be supplementary. You're going to have 4 angles that are one of the measures and 4 angles that are supplementary to those. And so it's kind of cool, because if you know just one angle, if all I knew, for example, was this top angle was 100 degrees, then I would know, okay, I've got 3 others that are 100 degrees. There they are. And the other 4 have to be supplementary, 80 and 80. And obviously, as I change the degrees, the other degrees will change as well. But they'll always be 4 congruent angles here, and then 4 congruent angles here, and the 2 different measures are supplementary. So at this point, we're going to go ahead and go over to our notebooks. Take some notes. Okay, let's take a look at our notebooks at the table of contents. In class last time we did 2.1, when angles intersect, and today we're doing 2.2, our second lesson, which is all about transversals, that red line you just saw. So find a new blank space, blank page in your notebook, and go ahead and at the top write today's date. This is lesson 2.2. And the essential question is, what happens when 2 parallel lines are intersected by a transversal? And then you can see that I've glued in this notes sheet that you picked up in class. There were 2 examples at the bottom, and I cut those off because otherwise it wouldn't fit, and I'm going to do those on the next page anyway. So you can see the bottom is vertical angles. So go ahead and get this set up. You've got to get your essential question down, get this cut out and glued into your notebook. So pause while you do that, and then come back and we'll go through them. So we already talked about what a transversal is. We don't really need to talk about it more, but go ahead and just for good measure, highlight that or underline it. That's our definition of a transversal. A transversal is a line that intersects 2 lines at 2 different points. And then I would like, if you have a highlighter or something like that, go ahead and highlight the transversal, because we're going to be referring to it a lot. So that's the transversal. And these other lines are parallel because they have the little flags. So the difficult part of this lesson is not finding the angle measures. That's easy. The difficult part is the vocabulary. There's a ton of vocabulary, and we'll practice it a lot in class because it just takes a lot of practice. And we're going to go through it now. So first is corresponding angles. So whenever you have a diagram like this, we're going to just sketch a little diagram. Whenever you have a diagram like this, and then we've got flags to show those are parallel, you always have 4 sets of corresponding angles. So let's read through the definition. They lie on the same side of the transversal and on the same side of the intersected lines. So same side of the transversal in this case would mean like they're both on the left side or they're both on the right side, but they're also on the same side of the intersected lines. So that means they're both above the intersected lines or below each intersected line. So we're just going to show one example. That angle is corresponding to essentially its exact counterpart at the other intersection, which would be like the top left counterpart, right? So this angle is the top left angle in this intersection, and it's the top left angle in this intersection. And so those are called corresponding angles. Obviously, we could have, the top right and the top right, those would be corresponding as well. And then we would have the bottom left are corresponding, bottom right are corresponding. And so in this diagram up here, let's go ahead and list them. We've got angle 1 and angle 5 are corresponding. And go ahead and see if you can figure out the other 3 pairs of corresponding angles, and then check back up here to see if you got them. And so when you're thinking about corresponding angles, just think like top left, top right. That's what we're looking for. If 2 parallel lines are cut by a transversal like they are in this diagram, then corresponding angles theorem tells us that corresponding angles are congruent. They will always be congruent. So in this diagram, angles 1 and 5 are congruent, 4 and 8 are congruent, etc. Same side interior, that's our next one. Same side interior, let's draw a little mini diagram here. These are parallel lines. They lie on the same side of the transversal again, and between the intersected lines. So again, we'll kind of focus on the left-hand side, but this time they have to be between the intersected lines. So here and here. Those are same side interior angles. Or we could be on the right-hand side, and those are same side interior angles. So in our diagram above, let's go ahead and show that we're talking about 4 and 5. And then on the other side of the transversal, it would be angle 3 and angle 6. And I hope you can see just from looking, oh, you couldn't see that. There we go. I hope you can see just from looking that those angles are not congruent. If we look at 3 and 6, this is obtuse and that's acute. They're not congruent. And in this diagram, you saw from the thing we looked at earlier, if they're not congruent, they're supplementary. So in this case, same side interior angles are supplementary. All right, moving right along. Alternate interior angles. Draw our little guy again. This diagram is going to become your friend. You're going to get so used to it. Alternate interior angles are non-adjacent angles that lie on opposite sides of the transversal between the intersected lines. So let's see if we can figure that out. Opposite sides of the transversal. So one will be to the left and one will be to the right between the intersected lines. So one on the left, one on the right, on opposite sides of the transversal. Those are alternate interior angles. So looking up at our diagram again, we've got 4 and 6 are alternate interior, 5 and 3 are alternate interior. So let's go ahead and write that down. And the alternate interior angles theorem says that alternate interior angles are congruent. I hope you can see that from the diagram. Okay, a couple more to go. Alternate exterior. We'll draw our little friend again. you know, just for good measure, let's make it go the other way. Alternate exterior angles are exactly the same thing. They're on opposite sides of the transversal, but this time they're outside the intersected lines. And so it would be outside, in this case above the intersected lines, and then we have to go below the intersected lines on the opposite side of the transversal, so down there. So take a minute and see if you can figure out, there are two pairs of alternate exterior angles in the diagram above, so see if you can figure out what they are and then check back up here to see if you got them right. Okay. So outside the intersected lines, in this case the parallel lines, on opposite sides of the transversal. And there's no theorem here, but we should know that alternate exterior angles are congruent. And you can see that from the diagram. They're either both obtuse or both acute. And then vertical angles is a review, but let's go ahead and draw, this time, I want us to mix it up a little bit. Let's draw our parallel lines like that. Let's draw a transversal that goes like that. It's important to be able to view this from different angles. So vertical angles are opposite angles formed by two intersecting lines. So in this case, this is just a review. Those are vertical angles. Those are vertical angles. There are four pairs of vertical angles. And so go ahead and list what they are by looking up at the diagram above and then check up here to make sure you got them right. And we know from class that vertical angles are congruent. And then there's one more that I wish was on here, but it isn't, and so we're going to write it in below. A linear pair. And this isn't new. We talked about a linear pair last class, but I do just want to recognize that there are a ton of linear pairs in these diagrams. So if you have room, let's draw our guy again, parallel lines. There are many, many linear pairs, but any two adjacent angles on this diagram, so any angles that share a ray, are and have the same vertex, right? They share a vertex, they share a ray. They are going to be a linear pair. They're not congruent, as we learned last class, they're supplementary, but there are lots of them. There are 8 pairs. So again, this is really good practice. I want you to go look up at that diagram above and see if you can list all 8 linear pairs, and I'll do the same. You can check in when you're done. So pause if you need to, but these are the 8 pairs, linear pairs, I guess. Any two adjacent angles are going to form a linear pair here, and we learned last class that any linear pair, those angles will be supplementary. So like we talked about with that little demonstration earlier, any two angles in a diagram like this will either be congruent or supplementary. So let's go ahead and put this into practice. Turn the page. And there are 2 examples that we're going to do here. So you're going to need to get them glued in. So go ahead and cut them out separately because we're going to need some space. And we'll glue it in. I've got like old-fashioned Elmer's glue here. I'm at home. I don't have glue sticks. Okay, there we go. So example 1, pretty straightforward. We have 2 parallel lines. We have a transversal. And I would like for you first to find the measure of angle QRT. And this is not an easy problem because angle QRT, if we look at it, QRT, I have no information about that angle at all. So I'm going to have to kind of work my way backwards. I know if I learn what this angle is, I can find this angle, right? Because these are a linear pair. So I think what I'm going to do is start with the two angles that I know something about, and that would be this angle here, that's x plus 40 degrees, and then this angle here, that's 2x minus 22 degrees. So what I want you to do right now is actually pause the video, and I want you to go back and look at your notes from the previous page and see if you can figure out what is the relationship, what's the vocabulary word that describes the relationship between those two angles. And then see if you can figure out, are those two angles congruent or are they supplementary? So take a moment. And I'm sure you all paused the video and went back and looked. But these two angles are on the outside of my parallel lines, right? They're on the outside. And this is my transversal here. And they're on opposite sides of the transversal. One's above, one's below. So they're on the exterior of my parallel lines on alternate sides of the transversal. So these are alternate exterior angles. And alternate exterior angles are congruent. And so we can set up an equation with these two pink guys that I have. So alternate exterior angles are congruent, which means x plus 40 has to equal my other angle, which is 2x minus 22. And I'm going to stop talking for a minute and solve this equation, and I'd like you to do the same. You'll get more out of this if you try it on your own and look up here to make sure you did it right. So I got x equals 62, and that obviously is not the answer to the question, but I know I'm getting there, right? If x is 62, then I can find the measures of these two angles. So what I'm going to do is look to the one that's easiest, and to me, the easiest is this one here. And I'm going to replace x with 62. So this angle measure, x plus 40, if I replace the x with 62, then 62 plus 40 isn't so hard. That's 102 degrees. And remember what we talked about earlier, that if you know one of these angles, you know all 8. So I'm going to go through now and mark what all 8 are. So I've got 102 is this one here. And that's an obtuse angle. So in this diagram, anything that's obtuse is going to be 102. I've got vertical angles here, 102. And then these should be congruent, 102. So those are my 4 obtuse angles. They're 102 degrees. And then obviously to find the others, these form a linear pair. So I just need to do 180 minus 102, which is 78 degrees, and the other 4 have to be 78. And once you learn something, make sure you mark it on your diagram. So I'm done. I know the answer. The measure of angle, we should write it in a nice little statement. The measure of angle QRT equals 78 degrees. So the first step here is to look for angles that you have some information about, figure out what's the relationship there. Are they congruent or are they supplementary? And set up an equation that will help you figure it out. Let's look at example 2. Go ahead and get it glued in. And in this example, there's a ton going on. It's pretty tricky. I want you to, should have said solve for x and y. Solve for x and y. So we're going to do the same thing. We're going to look for x, like where is x on here? It's right here. And so we're looking at this angle. And what I recommend, especially if you have a highlighter, is highlight the two lines that form that angle. So we've got this guy that's going straight up and down, and we've got this guy here. And what we'd really like to do is find a line that's parallel to one of those that we have some information about. And I want you to be really careful. We can't use this line because this angle formed by this line and this line is that entire angle, which we could figure out, right? 90 plus 36, but it's not, this angle is not corresponding to the 36-degree angle. It's corresponding to that entire thing, which is 36 plus 90. But I don't even need to go there because there's another parallel line over here. So we've got two parallel lines in the transversal, and we know that this angle is 126 degrees. So I actually have plenty of information here. These are corresponding angles, so I'm going to write that down. They're corresponding because they're on the same side of the transversal and same side of the parallel lines. Top left, top left. Corresponding angles are congruent, and that means we can set them equal. So 126 equals 12x plus 6. Go ahead and solve. So hopefully you got x equals 10. Let's go ahead and figure out y. Y is here, and that's this little angle. So again, the two lines that form that angle are that diagonal line and then this horizontal line. And so I need to look for a line that's parallel to one of those. And so the one I'm going to go to is this guy up here. So here we've got two parallel lines cut by a transversal, and you got to try as hard as you can to ignore everything else because the rest of it is irrelevant. These two lines, take a minute and see if you can figure out what the vocabulary word is that describes the relationship of those angles. So those guys are alternate interior angles, and alternate interior angles are also congruent, which means 2y plus 30 has to equal 36. They're congruent, and so we can set them equal. Go ahead and set up that equation and solve, and then look up here when you're done. So if you got y equals 3, you are a superstar. If I'm going too fast, obviously feel free to pause. I want to try one more example, but I'm making this up on the fly, so forgive me if it doesn't work out. Let's draw two parallel lines here. Drawing parallel lines is really easy when you have graph paper. But let's go ahead and mark that they're parallel. And let's draw a transversal. And this time, I'm going to say that this angle here is 2x degrees. And this angle here is, let's see, x plus 30 degrees. I think that's going to work out. X plus 30, a little hard to read. So I wanted to show this to you because in the other two examples that we did, the angles were congruent, and in this case they're not. These angles are on the same side of the transversal, so same side, and they're inside the parallel line, so these are same side interior. And you should be able to just see that they are not congruent. This one's obtuse and this one's acute. And so these guys are going to add up to 180. So it's a different equation that we're going to set up. They're supplementary. And so instead of putting an equal sign between them, they're not equal. We want to show that if we add them, we get 180. So we're going to take our first angle, which is 2x, and we're going to add our second angle, which is x plus 30, and that has to equal 180. So this is a very different equation to set up. Let's solve. Combine like terms. Now we have a basic two-step equation, so go ahead and finish solving. Pause if you need to. So x equals 50. I didn't tell you specifically if I wanted you to solve for x or find an angle measure, but let's go ahead and find the angle measures because it's not hard. If x is 50, then this guy, 2 times x, 2 times 50 is 100. So this is going to be 100 degrees, which means I'm going to have 3 other angles that are 100 degrees. We have 100 degrees, 100 degrees, 100 degrees. And then the other ones should be 80, and you can see that if I plug it in here, 50 plus 30 does equal 80. So everything else is 80 because it's got to add up to 180. All right, I have very little room to write a summary. So if you have this little room, you may want to consider going on to another page or squeezing over into this column. But go ahead and answer the essential question. It was basically what happens when a transversal intersects 2 parallel lines, what relationships are formed. So go ahead and write a couple of sentences there talking about how many angles are formed and what the relationships are between the angles, and then you're done.